Let's begin section 6, which is a summary of reproductive physiology. Genetic sex is determined by the sex chromosomes, which will either be XX or XY. Gonadal sex is defined by the presence of testes or ovaries. Finally, phenotypic sex is determined by the hormonal output of the gonads. Puberty in males and females is initiated by the pulsatile secretion of GnRH, which then drives the pulsatile secretion of FSH and LH. Pulsatile secretion of FSH and LH then drives the testes and ovaries to secrete their respective sex steroid hormones, testosterone and progesterone and estrogen. In males, the testes are responsible for spermatogenesis and the secretion of testosterone. Testosterone is synthesized from cholesterol by the Leydig cells. In some target tissues, testosterone must be converted to DHT by the action of 5-alpha reductase. Testosterone acts locally to support spermatogenesis, as well as on extratesticular target tissues such as skeletal muscle. Regulation of the testes is via negative feedback effects of testosterone and inhibin on hypothalamus and the anterior pituitary. Shifting gears towards females, the ovaries are responsible for oogenesis and secretion of progesterone and estrogen. Progesterone and 17-beta estradiol are synthesized from cholesterol by theca and granulosa cells, respectively. Theca cells synthesize progesterone and testosterone, and granulosa cells convert these enzymes by the action of aromatase. The menstrual cycle has a follicular proliferative phase and a luteal secretory phase. The follicular phase is dominated by estrogen, and the luteal phase is dominated by progesterone. Ovulation occurs on day 15 of a 28-day menstrual cycle. If fertilization occurs, the corpus luteum synthesizes steroid hormones to support the developing zygote. However, if fertilization does not occur, the corpus luteum regresses and menses occurs. Early pregnancy is supported by steroid hormones produced by the corpus luteum. And is directed by HCG from the trophoblast. The second and third trimesters of pregnancy are supported by steroid hormones from the placenta. Progesterone, estradiol, and prolactin levels increase steadily during pregnancy. In contrast to levels of HCG, which decline after the first trimester. Menopause is a cessation of menstrual cycles. During this period, the number of functioning ovarian follicles decreases, estrogen secretion declines, and the circulating levels of pulsatility of FSH and LH secretion increase. Now it is time to test your understanding of the material. Through a series of questions. First question. In which of the following causes of delayed puberty would pulsatile administration of gonadotropin-releasing hormone be effective? Hypothalamic dysfunction, Leydig cell dysfunction, androgen insensitivity syndrome. The answer would be hypothalamic dysfunction, because it is the pulsatile activity of GnRH on the anterior pituitary to then drive pulsatile activity of FSH and LH, which cause the onset of puberty. Leydig cell dysfunction would just be a dysfunction of testosterone production, and androgen insensitivity syndrome would just be a defect in the cause of development, both in utero and during puberty, but not affect the onset of puberty. Question 2. Which step in testosterone synthesis is activated by luteinizing hormone? Androstenedione to testosterone, cholesterol to pregnenolone, testosterone to DHT. And the answer is cholesterol to pregnenolone. Luteinizing hormone activates the enzyme desmolase, which catabolizes cholesterol into the pregnenolone precursor. Question 3. Which steroidogenic enzyme is not present in the gonads? 17-alpha hydroxylase, 21 beta hydroxylase, or cholesterol desmolase? The answer is 21 beta. The answer is 21 beta hydroxylase. You'll recall that 17 alpha hydroxylase is actually a special enzyme which is present in the gonads, and cholesterol desmolase is the common enzyme which is present in all aspects of steroid pathways. Question 4. Which hormone maintains the corpus luteum of pregnancy? Luteinizing hormone, human chorionic gonadotropin, estradiol, or progesterone? The answer is HCG. To review, the corpus luteum produces HCG during the first trimester of pregnancy, and afterwards, in the second and third trimester, the placenta takes over. So during this time period, it is absolutely essential that the corpus luteum be producing HCG. This is also the metabolite that we test for in home pregnancy test kits. Question 5. Which of the following organs are needed to synthesize estrogen during the third trimester of pregnancy? Corpus luteum, maternal ovaries, placenta, fetal liver, maternal adrenal cortex, or fetal adrenal cortex? The answer is the placenta. The answer is the placenta, maternal liver, and fetal adrenal cortex, all which are involved in the interplay between mother and fetus in order to produce estrogen during the third trimester. Question 6. Which period of the menstrual cycle does the dominant follicle produce most of its estrogen? Days 1 through 4, 5 through 14, 15 through 20, 21 to 25, 26 to 28. The answer is days 5 through 14. The answer is days 5 through 14. A good way to approach this question is to divide the menstrual cycle into either part 1 or part 2. Part 1 being the proliferative phase and part 2 being the secretory phase, which are characterized by high levels of estrogen and progesterone respectively. And you would expect that the estrogen would be most avidly produced by the dominant follicle during the latter part of the first phase, which would be days 5 through 14. Question 7. During which period of the menstrual cycle does the corpus luteum regress if fertilization does not occur? Days 1 through 4, 5 through 14, 15 through 20, 21 through 25, 26 through 28. The answer is again 26 through 28. The answer is again 26 through 28. And I say again because again we should be breaking up the menstrual cycle into part 1 or part 2. During part 2 is when the corpus luteum will regress if fertilization does not occur. This would be the secretory phase that is characterized by high levels of progesterone and where the decidua becomes inhospitable to sperm, to blastocyst implantation, and the sloughing will occur. And this is when the corpus luteum will most likely regress, which is in the last part of the menstrual cycle. Question 8. In a genetic male with a deficiency of 5 5-alpha reductase, which of the following masculine features are present? Testes, muscle mass, male hair distribution, epididymis, and deepening of the voice. The answer is actually almost all of them. Testes, muscle mass, epididymis, deepening of the voice. To understand this question, we should realize the relative contributions of testosterone and DHT to development of the male physique. The DHT is responsible for external male genitalia, the development of male hair patterns, the development of male pattern baldness, and sebaceous gland development and prostate gland development, where testosterone is responsible for every other aspect of male development. And the only thing present on this list which is responsible by DHT is male hair distribution. This concludes section 6 and also wraps up the reproductive physiology section from the Costanza textbook. This concludes section 6 and also wraps up the reproductive physiology section from the Costanza textbook.